By the mid-1970s, the MiG-25 had achieved credible worldwide recognition. It had become a source of some concern to potential enemies of the Soviet Union. Foxbat was the code name NATO gave to the MiG-25 interceptor. Foreign intelligence agencies were desperate for anything they could get on this new Soviet aircraft. Any information was gratefully received. The Cold War was actually a hotbed of espionage activities and minor political and military incidents. One famous episode during East-West confrontation happened in 1976. The MiG-25 found itself the focus of worldwide attention. 6th of September 1976, Senior Lieutenant Viktor Bilyenko hijacked the top-secret fighter to Japan. He flew the MiG-25 from the Russian Far East aerodrome at Chuguyevka to Hakodate Civil Airport in Japan. Along with the aircraft, the Japanese got access to the top-secret Soviet IFF codes, that's identification friend or foe, and other Soviet military secrets. The MiG-25 design included a high wing, that's to say at the top of the fuselage, swept back by 42 degrees. There were two big tail fins and two ventral fins to improve the longitudinal stability at high speeds. The specifications included a service ceiling well over 20,000 meters and a maximum speed of 3,000 kilometers an hour. That was what decided the general layout of the aircraft. The fact is that when you're near 3 times the speed of sound, the aircraft's structure gets extremely hot. Some parts can reach a temperature of 300 degrees Celsius. At those sorts of temperatures, traditional aluminium alloys lose their strength, so you have to use steel or titanium. Indeed, the American SR-71 was mainly made of titanium. The MiG-25 structure is mostly high-tensile stainless steel. We decided to use heat-resistant stainless steel. We very quickly mastered the technology and completed the manufacturing process of the fuselage and the other bits of the structure. It wasn't long before we could start actual production. Tests showed that the whole structure could withstand the kinetic heating of high speeds. Some of the structural materials were unfamiliar to the Soviet aircraft industry. They needed radical changes to the technology. With aluminium, the main way of fixing components and skin is with rivets. But for high-tensile steel, you need welding. At the Electric Welding Institute, academician Boris Patona was developing unique methods for spot and arc welding. They provided the strength and structural integrity that was needed. This was distinctive technology, unique to the Soviet Union. The fuselage was welded automatically in an assembly frame. As the frame rotated with the fuselage, automated welding guns were working on it. We'd found we couldn't just set up the fuselage and start argon welding, so we fixed it inside the rotating frame. And when the argon welding was finished, all we had to do was take the fuselage out. The fuselage was an all-welded structure. It was, in fact, a huge fuel tank. Next, the outer wings, the tail units, and some other bits were attached to the aircraft fuselage. Special insulating panels had to be fitted to protect the area around the engines from overheating. The panels were silver-coated. 5 kilograms of silver were used in their manufacture. Because of the high temperatures involved, new rubber and other sealing materials had to be specially created. And the canopy also had to be heat-resistant. Special fuel was required. Unlike regular jet fuel, it was heat-resistant and it could retain its properties at high temperatures. Obviously, both crew and equipment needed to operate in comfortable conditions, so efficient air conditioning and cooling systems were fitted. The R-15B-300 engines were developed in Sergei Tumanskaya's design bureau. They each developed 11,200 kilograms of static thrust in reheat. The R-15 was designed to give maximum performance at high altitude where the air is thin. At the time it was unique, the only high-altitude engine made in the Soviet Union. To optimize its performance, it had an electronic fuel supply system and a 3-position nozzle. The engine air intakes had movable wedges which automatically regulated the airflow according to flight conditions. The global standoff between the USSR and the USA forced the politicians of both countries into quick decisions with quick results. The revolutionary MiG-25 was designed and built in just 3 years. When I was the assembly hall manager, Mikoyan himself, Matyuk or Gurevich would say, "Well, why don't you fix the problem? We want you to sort it as soon as possible. This is not good, Comrade Stepanov. Don't you understand? This job is more important than anything else." The chief designers, in fact the whole Mikoyan Design Bureau, were technically very knowledgeable. They knew just what should be done and how. They knew which specialist to use to get the best results. They knew how to do tests. Artem Mikoyan set out to build cooperation with the best aircraft makers in the Soviet Union. And he succeeded. In particular, he set up good links with the Dubna engineering plant, and they went on to produce parts for the first prototypes and also for the production MiG-25s. December 1963, the first prototype is delivered to Zhukovsky Aerodrome. This is a reconnaissance version of the fighter, designated Ye-155R1. 6th of March 1964, Mikoyan Design Bureau test pilot Alexander Fedotov makes the maiden flight of the Ye-155R1. I remember that day very well. We had a potential accident during that maiden flight. It was quite cold, about -12 degrees Celsius. Earlier, we'd installed sensors on the aircraft to test the flight systems in flight. We had a remote health-checking system in the sensors, and soon after takeoff, I got a warning indication that the fuel pumps weren't working. Afterwards, it appeared that an important fuel agent hadn't been added to the aircraft tanks. It was a sort of antifreeze for kerosene. As you know, kerosene contains water, and during the flight, the water froze in the pumps. Luckily, Fedotov managed to turn back to the aerodrome and land. He was very lucky to have had enough available fuel to get back. If the flight had been longer, the engines would have been shut down. 9th of September 1964, the Ye-155P1 makes its maiden flight. It's the interceptor prototype, flown by test pilot Pyotr Ostapenko. You always treat a first flight like a newborn baby. I took off carefully, maneuvered the new baby round a bit, tried the engines at different settings and checked some of the new aircraft systems. I was doing it all very carefully and at subsonic speed, of course. I didn't go above 5,000 meters high, and then I slowly and carefully started my descent, came back to the aerodrome and landed. There were no serious problems in those early test stages. It is always the case with a new aeroplane that you get some minor problems, but they were solved. For example, the tests revealed a lack of directional stability at high speed. First, they tried putting an early version of the modern winglets on the wingtips. They called them flippers, but that didn't seem to help. So instead, they enlarged the tail fins. The high temperature generated in flight was another problem. It wasn't the aircraft's structure that was suffering, but the skin. After a few flights at high speed, the Soviet red stars had almost disappeared. Horrors. Nobody thought much about the red paint, but obviously we had to have red stars on the plane. After several flights, you could see the stars starting to peel off the aeroplane's skin. So next we had to develop a new heat-resistant paint. Within a couple of weeks, we'd got our new paint, and it worked. Everything was going well. Gradually, MiG-25 performance was improving. Full-scale production was arranged to be at the Gorky aircraft plant. Operational testing of the new aircraft started in 1965. There were up to 11 aircraft at a time on test at Akhtubinsk, each with its own mission. There were something like 700 different specialists from different organizations. We worked as long as necessary to get to where we wanted. If the weather was good, we worked weekends. Everybody was enthusiastic. They had this feeling that this aeroplane would be a real winner. Thing is, the MiG-25 was different to anything that had gone before. With its impressive size and its strange shape, it was picking up some odd nicknames. I was working as a flying instructor. I'd never seen the MiG-25 before. But then I became a test pilot. I was looking out of the office window one day and I saw this very unusual aircraft taxiing past. I thought, what's that? The shape was so weird. I figured that any fighter with pretensions to really high speed would look more like a rocket. But this thing didn't look like a rocket at all. And to my eyes, it didn't have the right shape to achieve good aerodynamic performance. So I said to a colleague standing next to me, what's that? He said, that's a Phantom. I didn't get the joke. I thought he was serious. But huge air intakes, wide fuselage, 2 tail fins, 2 great big jet nozzles, everything looked quite wrong to me. In July 1967, it was decided that the MiG-25 should take part in an official flypast at Domodedovo, even though operational testing hadn't been finished, as part of the 50th anniversary celebrations of the October Revolution. A loose formation of MiG-25s flew over the aerodrome in front of the distinguished guests. The new shape in the sky caused a sensation. One of those aeroplanes was flown by military test pilot Yegor Lishnikov. 3.5 months later, on the 30th of October, Yegor Lishnikov set out to break a time-to-height record with the MiG-25. After takeoff, he accelerated the aircraft in reheat and started a high-speed climb. He quickly exceeded the speed limitation. At altitude 1,000 meters, the aircraft started banking to the left. Lishnikov tried to correct the uncommanded bank with the right movement of the control column, but he was going too fast, and the result was what's called aileron reversal. Lishnikov's stick movement to the right caused an even bigger bank to the left. The airplane began a steepening dive. Yegor Lishnikov managed to eject, but because of his high vertical speed and low altitude, he had no chance. He didn't survive. The lack of effectiveness of the flying controls remained a problem during missile testing as well. After a missile launch from an outer wing hardpoint, the aircraft would sometimes roll on its back and dive steeply. Military test pilot Nureyev Kazarian was the first one to experience this. Immediately after a missile launch, the aircraft zoomed and started rolling over. I pushed the control column the opposite way and tried to recover the aircraft, but it didn't respond. It continued rolling and began to dive almost vertically. I still had no control. The aircraft was diving very fast. Only at an altitude of 12,000 meters did it start very gradually responding to the controls. At 10,000 meters, I finally got it under control and started leveling out. Eventually, I got it level and turned towards the aerodrome. A missile launch had never caused such an upset before. It was a big problem, and it had to be solved.